Hello everyone, welcome to another edition of GWF webinars. Today we will be discussing geo-enabling telecom network governance. And today we have two speakers with us to share their experience.
Yeah.
So our first speaker is Mr. Tomaž Šturm. He is the Undersecretary Telecommunications from Agency for Communication Networks and Services, Slovenia. Tomaž, would you like to say hi to the audience?
Hi, hello everyone.
And our second speaker is Mr. Josip Lisjak. He is the head of GIS from city of Pozega in Croatia. Hi, Josip.
Hi, hello to everybody. Good afternoon. I'm very pleased to be invited and pleased to participate in this webinar.
So to all the audience, please feel free to introduce yourself in the chat box. Each speaker will speak for 20 minutes. And after both presentations are done, we will have a Q&A session. So at any point during the presentation, if you have any questions for the speaker, please type your questions in the chat box and you will take them up during the Q&A session. So now without further ado, I'm going to start the slide for Tomaž.
Hello everyone. Today I will talk about broadband mapping in Slovenia. I will represent you the key data on that topic, the Geo portal that is publicly available, and of course, last but not least, I will also mention it about regulation. First of all, I have to mention the body of European regulators for electronic communications, BEREC. BEREC is composed of the heads of the EU member states, national regulatory authorities. We also have a national regulatory authority in Slovenia, and it's called ACOS, Agency for Communication Networks and Services. ACOS is an independent body that regulates and supervises the electronic communication market, radio frequency spectrum, radio and television broadcasting, postal and railway service markets. I would like to show you a short video presentation of ACOS and that what we are doing, so you will be you have an impression what we are basically doing as a national regulatory authority. Video. Okay, let's continue. ACOS has many divisions, and broadband mapping is dealing, and the division for the regulation of telecommunications is dealing with broadband mapping. We conduct the task relating to the regulation of the electronic communication markets. And in order to do the effective regulation, we needed the data, and for that purpose, we established open source mapping system where we have all the data we need for regulatory purposes. In those databases, we have spatial data, we have attribute or descriptive data, and those data are collected from different owners, One of them are owners of electronic communication infrastructure, and the other are public institutions like Mapping Authority or Ministry of Interior. Combining those data gives us complete overview of networks availability and population homes coverages by various broadband and mobile networks, which I will show you in next slides. But before that, I would like to go a little bit in the history so I can explain you the background, how we get to those data. In this timetable, let's say, you can see different dates, and for our job, one of the most important dates was in 2004, when the Mapping Authority started with development of the central database called Consolidated Cadastre of Public Infrastructure. In that database, there were data on railways, roads, and any line features in the field. The next important date is 2012, where we started with mapping process of network termination points, where we work together with Information Society, Directorate, and Mapping Authority. After that, all the data were collected in different databases, and in 2015, we were able to establish our own database. We put the data in those databases, we put all the data from public authority, and the most important data came from owners of electronic communications infrastructure. In order to achieve this goal, we have to also do everything on legal matter. And here are the three, I would say, most important documents on that topic. The most important is Electronic Communication Act that came out in 2012, where was written down that the owners of electronic communications infrastructure must collect the data on communication lines, and they must report those data to the Mapping Authority. And also there was if they don't do that, there is a fine for them. The next two documents are the Decree on the Provision and the Use of Public Information and Public Information Access Act, which allowed all those data to be publicly available. As I mentioned, we established our own database in 2015, and since this is an open source system, by that time, the tools, software tools that open source software tools that allow us to store and manipulate the data were also at that point so strong that we could use them, especially the PostgreSQL database and QGIS as a tool for making maps. In the database, we put lots of data, and we kind of divide them on basic data, additional data, and our own ACOS data. The basic data are cadastre of public infrastructure and network termination points from the owners of electronic communication operators. Beside that, we also use additional data like register on spatial units, business register, building cadastre, and population register. And of course, in that database are also our own data on retail mapping, on wholesale mapping, and some other data I will show you later on. Since we used those data from 2015, and when the legal background was, everything was okay with the legal background, last year in 2019, we published a geo-portal of all of those data. This portal is publicly available, and the main purpose of this geo-portal is to reduce the cost of building very high-speed networks and to encourage sharing and joint construction. Geo-portal allows public access to our ACOS data and all other data from other services in one place. This is quite important because public can get a lot of information about certain location in my country in only one place. Main goals of providing those data are related to higher transparency of operation and proactive publication of special information. Our geo-portal, at the moment, we have 65 different spatial layers that are in 8 groups. The users can get quick insight into various types of electronic communication infrastructure and their descriptive data. They can review fixed and mobile network coverages. Those data are made by ACOS, and the users can, based on those data, compare providers and options for electronic communication network access for every address in Slovenia. And of course, when we do some kind of spatial analysis, we can easily put those data also in our geo-portal so that we can show the public what we are doing and what are the results of our work. Now I will show you the, I would say, most important data we are using in our work for effective regulation, and of course, and that are also very interesting for public. First of them are network termination points. Network termination point means the physical point at which a subscriber is provided with access to public communication network. Those network termination points are usually located on the house address. We show the people data so you can see, do you have an optical connection, cable or copper twisted pair connection, Wi-Fi or some other connections. When you look at our geo-portal, you can get the data. First is the location of the network termination point. Then what kind is technology? That means it's like fiber or optic or copper. Then who is the owner of this network termination point? For every building we have data, this is a household or not. And of course, you also get the minimum speed at this certain location. And we also have a network termination point divided. So if this point is active, that means is in use or is not in, or it is not active. In nowadays, that would mean if you have some house, you have an optic and copper connection. So the optic connection is active and the copper connection is there, but it's not active, but it's still possible to connect. The next data are electronic communications. Electronic communication networks are transmission systems that allow the transmission of signals by wire, optical or other electronic means. We collect data on electronic communications in 3 different types: points, lines, and polygons. As you can see, for every different shape, we have a lot of data. Let's say for points, we have antennas, antenna tower, base stations, radio stations. And for electronic communication lines, you can see where are the optical communication lines, copper coaxial communication lines, copper twisted pair communication lines, other lines, and of course also for electronic communication areas. That means that is a shape of the building on which there is antenna. And we also put all those data in our Geo portal, and they look like that in there. When you turn on the electronic communication objects, you can see, and you click on info, you can see what kind of object is there, where is the position of line. That means is it underground or above ground, what is the type of line, who is the owner of the line, and very important also, what is the accuracy of the line, so that you can check, that you know how sure you can be on the location of the line in the field. The next data are fixed broadband coverages by speed. These are data that are done by ACOS. We are using 200 meters grid cells, where every cell tell you if there is a household or building with internet or broadband connection. And we divided, we made 3 different coverages. One just tells you if there is a broadband connection or not, and then we made 2 other coverages where we made it based on the speed, in the connection speed. We used, for those data, we used building cadastre, population register, and network termination points. The next data are mobile coverage data. That means that these are theoretical data on coverage of 2G, 3G, and 4G technologies for main operators in Slovenia. We used a lot of input data to theoretically calculate this coverage for the whole country. And for those data, for those coverages, we use the input data like terrain profile, forest location, building locations, building heights, radio terminals, frequencies, and so on. So the people, based on those coverages, they can check if they're at certain location, they can get a 4G connection with the cell phone, let's say. And beside that, we also made drive tests. That means that my co-workers, they drove on the road network around Slovenia. They made about around 6,000 kilometers, and they measure the strength of mobile signal for all the technologies, I mean 2G, 3G, 4G, for the 4 main operators in Slovenia. And now our next task is to compare those data from drive tests with the theoretical calculations, and maybe in that way we can improve the results of theoretical calculation of mobile coverages. As I mentioned in the beginning, this portal also this Geo portal is also intent for intention on planned construction. So you can get also data, those data there. For every planned construction, there is every planned construction is based on settlement. So for every settlement, you can check what type of investment is going on there, who is investor, when, which year the construction will start to going on. And for these purposes, those data on GeoPortal are connected with the portal of intentional planned construction, where the investors must put the data on the planned construction, so the owners of communication can join to this construction. That means, in the end, less digging, less pipes underground or above ground. And I can say that in last year or 2 years, there was quite a big rise of intentional planned construction, and that's it. Besides the data, our GeoPortal also allows public to do some other stuff that are connected with GeoPortal. First of them is that they can make a printable map in PDF form. That means that the user can turn on the layers they want to and set the scale, and then this PDF can save to his computer or her computer, and those PDFs can be then used in many ways, like reports or some other. GeoPortal also allows searching by address, so you can search every address in Slovenia, and then the GeoPortal is zoomed in on that location, and then you can turn on any layer you want, so you can get close to get detailed information about infrastructure in a certain location. We also, this GeoPortal also allow, we call that fast web analysis, when you can make a quick website analysis on investors, types of network termination points or minimum capacity based on municipality or settlement level. So basically, you just get a comma-separated value file, which tells you how many network termination points is at some certain region and what is the minimum capacity of those network termination points. We are dealing with this portal for more than 1 year. We are basically trying constantly to improve it, and one of the improvements is that we constantly put in this portal new data sets, and we update the existing data set because data are alive. We are also trying to implement web future services from other public institutions. We are dealing with the user interface. We want to make it look better, and one of the most important things is faster in performance, so for better user experience. And we are doing new analysis, and we are trying to publish those data on the GeoPortal. In the end, I will say the GeoPortal, it's quite a huge achievement for ACOS, and we are really glad that people or public are quite satisfied because they get so many information in one place, and the information that they didn't even know that they exist. Thank you very much.
Thank you, Tomaž. So now I will start Josip's presentation. Josip, now you have 20 minutes.
Okay, thank you, Sarah. Well, hello again. My name is Josip Lisjak. I'm a Master of Engineering in Geodesy and Geoinformatics. I work in the city of Pozega. It's a city in Croatia. Besides this, I'm a PhD candidate on the Faculty of Geodesy. So today I will talk about digital transformation into the smart city, or how the cities can contribute to good governance in the geospatial way overall, and in particular to the good telecom network governance on the case study of city of Pozega. So I will show a few examples of what we do with geoinformatics in our city. So first, to say a few basics about digital transformation and how do we see it, what drives us to do this. Of course, first thing of all, these are disruptive technologies. So I try to emphasize here on this image. Actually, this is an illustration taken from one number of Geospatial World magazine. So I emphasized with these red squares what of these key points could be closely related to the connectivity, or to the internet or telecom networks. So within technology drivers, this is cloud as a platform and the Internet of Things. And then within market opportunity, this is crowdsourced data. So without connectivity, there is no crowdsourced data. Within intelligence, this is digital vulnerability and cybersecurity. And for me, the most interesting thing, when we take a look way forward, this is this last point, X as a service. So everything is a service. And I will say a few words about this later. Besides these disruptive technologies, what drives us into the digital transformation, or what drives the cities into the digital transformation, are, of course, law regulations. There are some laws on national and local level that oblige us to do this. And then there are financing opportunities for the digital transformation projects within EU funds and national funds. And of course, there is competition among cities, because everybody wants to be modern, everybody wants to go forward, to be progressive. And the main thing I wanted to stress out here is that the geospatial business drives telecom network to develop, and vice versa. Good telecom network quality drives geospatial business forward also. So when we think of activities that we perform to digitally transform, we perform activities as users. So we use some platforms and systems which are developed on national level, like for instance, like my previous presenter showed. There are some national regulatory bodies also in Croatia with the very similar GIS systems. So we use the national spatial data infrastructure to perform spatial analysis in investment planning. We use some systems which is developed on national level to issue building permits, etc. But also we perform activities as developers on our own. So we implement our geoinformation system. We provide data sets through this system to the users, to the outside users. And there are several different applications which we built. I will show them later. So for instance, this is Communal tax system, then our roads database. We have our own asset management, because as a city, we have many properties in our ownership. We have several thousand parcels owned by the city. Then we have a GIS system for recording illegal landfills. There is also agricultural land administration program, WebGIS, etc. I will show you just a few of them, how they look like. So the first one is, for example, our greenery cadastre. We use a greenery cadastre to determine which green areas in the city should be paid for the maintenance by the city and which should be paid by some other body. So this is the example of the view how the person who is in charge of maintenance of the green areas, of the grass. So he's in charge, for instance, for cutting the grass. He sees the entire street, and on the field he couldn't differentiate which surfaces should be cut by him and which shouldn't, so he cuts everything. And afterwards, we use a GIS system to determine who should pay for what. So on the left side, there is a screenshot from GIS system. And on this example, for instance, these green areas inside the red line, this parcel is paid by the city, and outside are paid by the railroad authority, because this is the ownership of railroad. So this is just one example how we use the greenery cadastre. Okay, the next example is our communal taxation GIS system. So we also implemented the GIS with all the built structures on the field, all the building. It's not important with this whether they are legally built or illegally. We evidented everything. And besides this GIS system, which is technically on the open source technology, so the technology is the same as the used in Slovenia. So we use PostgreSQL database in combination with QGIS as a GIS client software. We use GeoServer to publish some services, and also some custom jQuery, Bootstrap libraries, and maybe some basic HTML to do some web to publish some web GIS applications. So this is on the right side example of our map of georeferenced photographs of each built structure, each house, each building under the administrative area of city of Pozega. We like to call this our own Google Street on steroids. So why do I say it's on steroids? Because we covered every single street under the city administrative area, which is not the case for the Google Street. There are some areas which Google vehicle did not pass through. So the data on the Google are missing, but we have georeferenced images of every built structure on the field. And we use this system to charge for communal tax the owners of these buildings. Okay. Well, the next example is GIS web viewer for available agricultural land. We actually developed this on our own within the city administration. It's a simple GIS viewer where we provide the interested citizens and farmers with the information about agricultural parcels which are available for them to use, whether to buy or to lease or to use it in some other form. So they can easily see what is available just by overviewing this entire application, and see other attribute data about every parcel. So we use this to increase the usage of agricultural land, which is not maybe at the time in production. So we try to encourage higher agriculture production on our area. So this is how we use this GIS example. And the next example is very similar to the previous presentation that Tomaž presented. We built our own telecommunications lines cadastre. So at the time when we were starting to build this cadastre, we couldn't use data sets from the national regulatory body or from the operator. So we wanted to build our own system because we had our interest. We are charging the right-of-way compensation to the telecom operator or to the owner of this telecommunication line. And in order to determine what is the length of lines on each parcel, land parcel, we needed it was necessary to implement this kind of GIS telecommunications lines cadastre. So as probably most of you recognize, this is a simple QGIS view. This consists of lines, of telecommunication lines with several attributes, but just the ones that we need. So this data model is pretty simple because we needed just the length and the sort of line, whether it is cable or canalization or line in the air, above ground. And we overlaid this with our register of properties, with our spatial register of properties owned by the city of Pozega. So once we overlay this, we perform the simple GIS analysis or simple GIS calculation and get the result of exact length of each lines for each cadastral parcel owned by the city. So we use this process to regulate between city of Pozega and telecommunication operator to regulate our right-of-way compensation. They are paying to the city yearly a certain amount based on this length calculated on this way. But also this is very useful for them because they, after this was built, they could then register their utilities in land book with the right of way, and they could claim their rights to access and maintain the infrastructure. Before this, every intervention in the field, every digging that they had to do, they had to struggle to prove that they have the right to access this land, that they have the property there. This way they registered all the telecommunications line and the entire network to the land book, and now they have a right to access the land for the maintenance issues. So this is actually a mutual benefit system. Okay. Besides this operation system where we provide some GIS for the regular daily maintenance, we also can contribute as a city to the planning process. So we have this GIS which consists of many different data sets, and we use it as a decision support system. So you can do classic spatial overviews, progressive analytics. This is then data-driven decision making, and most important of all, decisions made this way are supported and deliberated political decisions. This is important for the decision makers, for the politicians, when they have to elaborate why they made some decision, whether this is investment or buying some property to the city council or to the citizens, then they have an elaborated approach and a thing to prove. So this is actually an example of spatial analytics to find an optimal location for the school within our city. It's a classical multi-criteria decision analysis. We perform this whenever we have to plan a new location of our investments, but also we provide this as a service to the users outside, to our citizens, to business owners, if they need to perform some spatial analysis, but they don't have a built system like this, and they don't have access to the data sets. This is also very important for the telecommunication operators, because nowhere is competition in the telecommunication industry more intense than in the wireless sector today, I would say. So while most the second generation and even third generation networks have rolled out, now they have to think about redesigning their network because of the new 5G technology, or even in some documents on the level of European Union, like Shaping Europeans' Digital Future, they already mentioned 6G, and that the Europe needs to prepare for the 6G. So this is forcing carriers to redesign all or at least some parts of their networks. With this system, they can perform sophisticated GIS analysis on optimized geographic data, and they can reduce planning costs overall. Some preliminary analysis with GIS use customer data, terrain data, land ownership, physical plans, and many other data that we can provide as a city administration. So when using GIS to limit the number of design iterations, actually provides significant savings for telecommunication planners, I would say. Yeah? So they have then visualized and elaborated result for their decision, and for instance, for choosing a new antenna location or something similar. So besides this GIS analysis, as a key point, I would like to say that the cities, and the city of Pozega has many different data sets in production and maintenance that are very useful to the other sides, to the outside bodies, to the telecommunication operators, to the citizens, to the businesses. So, for example, we produce and maintain this data on the list, base maps. So there are digital orthophotos, and there are also some digital orthophotos in very precise and very large scale, as you can see on the left image. We then have cadastral plan, point of interest, also register of spatial units. We have a physical plans on several levels, which is, by my opinion, maybe most important data set. Then we have a build constructions, as I showed, communal zones, entrepreneurial zones, everything that we do and every decision we made while we regulate something, we transform this into this space. We georeference this and publish this as a data set. So also utility, communal infrastructure register, where we maintain the data on parking places, roads, cemeteries, public lighting, urban equipment. So maybe public lighting data set is very interesting for the telecommunication operators, because they can see where can they put these new microcells for the 5G or something similar. We have also data set planned construction work. This is also until now showed as a very useful data set, because the citizens and some other planners, architects, etc., can see what is the planned construction work. This is not yet in the field. This doesn't exist. This is an abstract data set, but they can see what and where will be constructed in the future, or at least what is the plan of the city management, what will they build. And of course, there are 3D models and point clouds, which we collect and put into the database on the daily basis as we acquire some new data sets in this way. Okay, of course, all of these data sets and data systems have their own formal data model. This is just an example of UML diagram for some of them. Some of them are simple, and other are more complex, and all of them are pretty interoperable and can be extended. It all depends on our needs. Okay, now when we think of the first slide where I mentioned this X as a service, this, by my opinion, is very important, because this is the future. We need to publish more web services. I would say the cities have a very wide range of data sets under their authority, and they could provide many useful data to the other users. Within this, we need to respect norms and standards. Within the Inspire directive, there are simple implementing rules, which are guidelines to the data set providers. How should they structure and implement their GIS system, and we should follow these rules. And then to build quality spatial data infrastructure, because everything is connected. On national level, there are several GIS systems which are used by the local levels. Also, we provide our data sets through the web services, and I think this is one geospatial ecosystem which should be built on top of the SDI rules. So what we gain with this, if we do this, we gain that we facilitate a good telecom network governance. We have then a good network access, and to have a good network access, this is very important for us also, because then we can use progressive disruptive technologies. This enables us to use new technologies which are based on good connectivity. And I would like to show you next example on which we are very proud. So this is just to illustrate my point of view. On the left side, probably half of the attendees of this webinar would say that they see some old lady, and the other half would say that they see a very young lady. Actually, both statements are true. Everything is in the eye of the spectator. So this is like the situation on the right side. For this guy on the left, this is 6, and for the other guy, this is 9. And why am I saying this? Because I would like to make a point of how disruptive technologies help us to eliminate this subjective factor in human-to-human interaction. So this is example of maintenance of roads. So how this works within the city administration. We have a road maintenance department, and on the daily basis, some citizens call, and most of the time they are upset, they are yelling on the phone, and they are making some damage report. And the guy who is listening, the employee of the city, actually, based on this, he imagines that there is a huge problem, there is a huge hole on the road, and then he issues a repair order with emergency. Building operative is on the field instantly, but already there rises the first problem. When they go to the field, they don't know where exactly is this, because all the communication is made by the phone, and they don't know what exactly to expect. So they imagine some huge hole, like on the photo on the top of the presentation. But actually, when they go to the field and examine the thing, it turns out that this is some small damage like this here, and that shouldn't be repaired immediately with some urgent measures. It makes additional costs. So what are we doing to reduce this kind of noise in human-to-human interaction? We are implementing something called the Smart Road Maintenance System. In order to implement this, we need very good connectivity, good telecom network connectivity. It is based on artificial intelligence, and it is designed and developed by our local company from Croatia, from a city called Slavonski Brod. It's near to Pozega, and we are implementing this pilot project to the city management. So basically, this system uses simple smartphone device which everybody has, and his camera, integrated camera, and integrated GPS receiver. So we use this when we drive through the city. We make a video of the city, and the artificial intelligence within this system automatically recognize and records to the database elements of the roads. So these elements are vertical signalization, horizontal signalization, some holes, damages on the road, etc. Afterwards, everything is geo-referenced in a GIS system, and you can see the element of the road on a map, geo-reference with its coordinates and some additional attributes which we choose. We will define this when we implement this pilot project. So I would like to show you how this works live. So please, Sarah, can you show the video? So on the left side, you will see how the system captures elements of the roads. It flashes, green, red flashes. So he captures the holes, the potholes, etc. On the right side, you can see the map. So afterwards, you can try to find the holes. For instance, this is a small hole. To click on the map, and this is registered in a database. You can see its video and its location. And then you can make a repair order, and the concessionaire or the company which is maintaining the roads, or which are doing the repairs, can see the location of the element from their side in application, and that way we reduce this human-to-human noise. We make some savings in financial way and in the time resources, etc. So we are very proud of this system, and we are expecting, we have high expectations from this system. So this is it. Finally, I would like to stress out or to make a key point that the main city resource is space. So the city manages space, and when we combine this with the information communication technologies, then we talk about geoinformatics. And within these systems that I showed earlier, what we gain? We gain reduction of human errors, we remove misunderstandings, we remove misinterpretation, and we enhance transparency. And why do we do this? Because we want to fulfill our obligations to the law regulations. We want to increase our income, as I showed with the example of GIS for telecommunication lines. We introduce new systems in economy and for the citizens, so we provide a service for them, and we create stronger reputation of city government and better efficiency of city administration, as well as every local stakeholder on our area. So this is it from me, and thank you for listening.
Thank you, Josip. So now I would like to invite Tomaž on screen. We will start our Q&A session.
Hi.
Hi, Tomaž.
Hi.
I still cannot see you, though.
Yeah, I don't have video, just audio at the moment.
All right, no problem. So thank you for the presentations. Both geoportals are actually very impressive. I can see that all telecommunication data is there, like the speed, the type of services, etc. But do you also have analytics capability on the data? Like, do you monitor their performance? If there is any complaints from the users, do you also monitor that or no? Maybe Josip, you want to start?
Sorry, this is
yes, Tomaž.
Tomaž.
Yes.
Sorry, I'm so sorry. Yes, Tomaž.
Yes, we are also monitoring those data. We have a special web page, ACOS.test.net, where the users can check what is the speed, and we get all those data. And in the next version of GeoPortal, we will also put those data to the public, so they will see where the signal is good and where not.
Okay, and Josip over there as well?
Well, it's not our main data set. We implemented this GIS just for this purpose of increase of income from the right of way. So we implemented this for this purpose, and regarding that, we created the data model as simple as possible. So we have only these attributes that we need for the registering the right of way in the land book and to making a contract between us. So this is maintained by the telecom operator, these things, these analytics.
Okay. Maybe for Tomaž then, this question is for you. During COVID and maybe now after COVID as well, the demand for telecom service in residential would be higher than in offices. So do you have that kind of analysis as well? Based on your data?
Not yet.
Okay. Because I think location would be very useful in this analysis.
Yes, I know that only the operators, they say some stuff about how the networks were full of traffic, but we didn't do any analysis yet.
We do have a few questions from the audience. From Mr. Rao Mapati, he is asking about the challenges faced in putting data in the cloud. So how do you manage the security of the data? Maybe Josip, you like to start?
Yes, well, actually, for now, we use our own server. We use our own server, which is located in the city premises. And now, actually, believe it or not, we are struggling with acquiring HTTPS protocol. So we are struggling with this for now. But security data is a subject of a separate department, so I'm not too familiar with the subject. I will be pleased to do some short research and answer afterwards if somebody wants.
Okay. Okay, but most of the time, as I understand it, for GeoPortal, only the metadata is being published. Like you don't own the raw data.
Yeah,
right?
Metadata are in the metadata catalog within the NSDI, National Special Data Infrastructure. But besides this, we actually publish our services, like a web map service or web feature service. And we provide our data within our GIS viewers also. So
for visualization.
Yes.
And Tomaž?
Analysis, they can come to the city. We formed some separate office, and the interested party can come to the city and to give their, I would say, criteria or everything which demands the analysis, and we perform GIS analysis for them. If we have enough data sets.
Right. Yeah. And Tomaž, what about your data security?
Basically, we have all the data in our premises, and we have a computer squad or team that they take care of security and so on.
Okay.
And of course, there is a backup every day and so on, but yeah, the computer team takes care of internet security and everything.
Basically, they are safe.
Yes, I believe so, yes.
The question from Mulwa Ndao is the installation of 5G set to run on a new hardware, or the existing infrastructure is designed with upgrade capability? Josip?
Well, I'm not sure if I understood the question, but actually 5G is not in place yet, at least in Pozega. For now, we have just one city in Croatia, which is preparing the infrastructure for the 5G. But also, I think that they are planning and they are thinking of hardware and to I would say, combine these two things and to develop simultaneously. It's the city of Osijek, and nowhere else in Croatia 5G is yet in place.
Okay. Yeah, actually 5G, it will take more infrastructure. So on top of the existing ones, we need to build new ones as well.
Yes.
And Tomaž, any thoughts on 5G? What's the development over there?
Basically, I think that we have at least one testing station working already, but that's it for now, because we are kind of trying to make a public announcement for the frequencies next year, and after that, I think the 5G will start a little bit faster than now.
Okay. Yeah, actually, we did the poll just now with if you think 5G will COVID-19 will slow down 5G rollout in cities, and 80% said yes. So maybe not this year, probably next year, 5G will again restart the rollout. And Josip, you were already talking about 6G. So any any elaboration on 6G?
When I was reading some material from the EU, there is a document or initiative called Shaping Europeans' Digital Future. Within these pillars of the Shaping Digital Future in Europe, there is a statement that Europe should prepare already for the new infrastructure for the 6G, and we should think in this way in long-term planning.
Right. Okay. That's interesting. So we have 2 minutes. I'm going to give you each 1 minute to share your future plans with governance of telecom communication and network services. So Tomaž, would you like to start?
Okay, I can do that. Basically, my thoughts. I hope that we will work together with the owners of electronic communications infrastructure to get the best possible internet connection to people as possible. That's it, because now in the COVID-19 it was shown that people need good and reliable internet connections at their homes, not only at workplace.
Okay. And Josip, last word?
Well, I hope we will stay progressive and develop and keep step with the rest of the world. Also, I think that when we think of development of geospatial business and telecommunication network, that there should be more coordinating activities. We should be coordinated and to use each other's data, because everything is I think that the strength of spatial data infrastructure is very important, and it is in the spirit of Inspire Directive afterwards. So this is my key point. I think we should coordinate more in our next development. We can learn from each other and use each other's benefits for ourselves.
Fantastic. So thank you, both of you, for an interesting presentations. And thank you to the audience for staying. This webinar is recorded. You will receive the recording tomorrow by email. And please do join us again. In 2 weeks from now, we have the next GWF webinar. So thank you so much. Thank you, Tomaž and Josip. Bye-bye. Stay safe, everyone.
Bye.